All right, this is our fourth and final video of graphing trigonometric functions. We've gone through sine and cosine, and then we did some examples of sine and cosine, and then tangent was in the third video. And now what we're going to do is translate all of these graphs. So what I'm going to do here is just kind of take a second to these are the notes now. Take a second to just soak in what these functions here look like. Okay, we still have our a and our b values, so we still have a vertical stretch. We still have an effect on the period, which is a horizontal stretch or shrink, and the a could be a vertical stretch or shrink as well. We call that the amplitude. In the sine and cosine graphs, I'm just going to write this here. The absolute value of a is the amplitude, just so there's a little review. B helps us find the period of sine and cosine is 2 pi over the absolute value of b. That's the period. So what we have now here are h and k values, which are going to act as our translations. We're going to have a horizontal shift and a vertical shift from h and k respectively. So I have this here kind of like here first is this is what you do and kind of steps to do it. Really the important idea here is that we are shifting the graph of the function that has been stretched with a and b. We're going to shift that h units horizontally and k units vertically. So what you do first is kind of up to you. But what I like to do is kind of do a sketch of this, either one of these two graphs first. So if it's sine, I'm just going to find out what the period is, and then, split that into fourths, and then do my sketch of my sine graph, and then I'm going to worry about shifting it left and right. So this would be the 2 pi over b, and this would be whatever a is, and this would be whatever negative a is. And I would kind of do a little sketch of that, and then on my final graph, I would shift it however I need to shift it. And then obviously if it's cosine, it's kind of the same process. You find out what 2 pi over b is as your period. And I'm just going to write here that this is sine. This is cosine. Go through that same process, maybe make a little sketch of what the graph would look like before it's shifted. Remember, cosine starts at its maximum, and then we'll come back and end at its maximum. Halfway through, it hits its minimum, and it's got these intercepts between the max and the mins. Now these both show a being positive. If a were negative, then obviously we would have these reflected graphs here. So the red graphs are if a was negative, and do this here. The blue graphs are going to be if a were positive. All right, so take a second if you haven't already and jot some of this stuff down. I think it's going to make a lot of sense. We talk about a being negative and how that has an effect on the mins and maxes. They end up flipping spots. X-intercepts or the midline intercepts, if we end up shifting it up or down, stay the same. So take a second, jot that stuff down, and then we'll talk about tangent. So it's the same idea with the tangent function. Same idea of a and b helping us get a graph first, and then we're going to shift it h units horizontally again and k units vertically. All right, now a and b, a for the tangent graph isn't really called the amplitude. It just tells us what the vertical stretch is. Okay, the graph is going to be stretched by a. What it tells us is when we end up graphing it, we have our asymptotes. We'll get to those in a second. But halfway to the asymptotes, whatever that value is halfway to the asymptotes, that's how far we're going to go up and down to a and to negative a. So the tangent graph is going to have points, those turning points halfway between the asymptotes. It's also going to go through the origin, before it's shifted by h and k, and it's going to look something like this. Now those asymptotes happen at odd multiples of pi over 2, or if there's a b value involved, pi over 2b. And this would be negative pi over 2b. The period of the tangent graph is pi. Well, if there's a b value involved, it's pi divided by the absolute value of b. I didn't put that up here, but I guess we kind of did. There's the period of the sine and cosine graphs. So let's take a second now that we have all these notes down. Let's take a second now and do a few of the examples in the example packet. So here we are in the example packet here. I don't have these done. This is from one of the earlier videos. I just wanted to just remind you of some of these graphs that we did and just say these are what our graphs are going to look like. We're going to graph them just like these with the a and the b involved, and then we're going to shift it h units left or right and k units up or down. So the first one we're going to take a look at here, we might have done this one in class. If we did, you can fast forward through this and get to the next one. But the first thing we're going to do here is identify what graph we are graphing before it is translated. Okay, so negative 3 sine of x, there is no b value shown there, so b equals 1. So I have a no b value shown in my original graph here. So what that means is our amplitude is 3. Amplitude is always positive. Our period is going to be, since b is 1, just 2 pi. And I am going to just make a note to myself that it's reflected because of the negative. So sometimes I even, well, we're going to do a sketch here. I was going to say sometimes I do a little sketch to myself to remind myself it's a negative sine graph so I don't mess that up later on. But we're going to do a sketch here, a little bit nicer sketch to get started. Holy man, let's make that a little bit nicer. All right, so the first thing we want to do in our sketch here is recognize that we have a period of 2 pi. I'm just going to split this into fourths on my sketch. No need to split this into eighths here. And we're going to have an amplitude of 3. So this really isn't a scale right here, but that's okay. And it's a negative sine graph. So I'm going to take the negative into account when I do this. And I'm just going to recognize that sine starts at the midline and it ends at the midline. Halfway through, it goes through that midline again. Okay, until we shift it, the midline is the x-axis. Because it's negative, it's going to start by going down and hit its maximum, and then 3/4 of the way through, it's going to hit its, it's going to hit its minimum first, and then 3/4 of the way through, it's going to hit its maximum. So this is what this graph is going to look like before it's shifted. And if you want to do that, on this graph that we have here, if you want to do one first, you can. I kind of like to do that sketch first and then come over here and put the finished product, start putting the finished product together. So what I'm going to do here is I went out 8 lines, okay? Either 8 lines or minimum 4 lines is what you want to use. I'm going to take a second to label these ones here. They're all by pi over 4 then. Just helps you get an idea of what your scale of your graph is here. Negative pi over 4, and this would be negative pi over 2 then. So a good thing to now look at is how we're going to be shifting this thing. We are going to be shifting this graph because it says plus pi over 2. We know where we're going to shift. Just going to write my shifts right here. Left pi over 2. And we're going to shift it down 1. Okay, because of the -1 there. So as I'm looking at this, if we're going to shift this down 1, the way that I have it here, this would end up being my midline right here if I left this as the x-axis. And since I have an amplitude of 3, I'm going to have to go down 3 units. So I'm going to go way off this graph here. So what I would suggest in this problem in doing is making a new x-axis right here. And you can do this anytime you want on any of these graphs. I have a nice little line tool here I should probably use a little bit more often. And that's why I don't, because it never works very well. But there's my new, what I'm going to use as my x-axis here. Okay, and I'm going to even write that next to it just to show this is, I knew there was a reason I never use this thing. It doesn't work very well. So I'm just going to write here, this really is now going to be my x-axis. Okay, I'm going to leave the y-axis where it is. And now if you'd rather label your x-axis instead of your y-axis with those values, you can shift those up and do that if you want. It's a little late for me to do that here. So I'm just going to leave them right on that midline right there, but know that this right here is my x-axis. So since I'm making that my x-axis, I need to now recognize that this is -1, -2, -3, and -4 here. This is 1, and this is 2. Because there's an amplitude of 3, I know that my maximum value is going to be at 2. So I'm just going to put this horizontal line here to kind of show that's where my maximum values are all going to be. I'm going to have all my minimum values at -4. Okay, so it's going to bounce back and forth between those pink lines that I just drew in there. Before I shift it left and right, just to get an idea of what's going on here, I'm going to do a light graph of what it looks like before it's shifted left or right. Not necessary, but I think it's kind of helpful. So I'm right now I'm only accounting for that shift right there. So I'm going to start right there at the midline. It's going to end at the midline at 2 pi. Halfway through it goes through the midline because it's a sine function. And that means it's going to hit the minimum there because it's negative, and it's going to hit the maximum here. And so this looks like this. Just a little sketch of what it looks like before it gets shifted left to right. Okay, and I didn't put my square root of 2 over 2 points in yet, but I will when I do my final graph right there. Okay, and like I said, that gray graph I just drew, not necessary, but I think it's going to help kind of show how this thing is shifted left to right. So what we know here, what we know now is that that left pi over 2 on my graph means that all these points are going to be shifted that much, those 2 units on my graph. So in other words, that point right there is going to become this point right here. That point right there is going to become, if I shift it left 2, that point right there. And I'm going to keep going. So now I have my 5 major points of this graph, but what I want to do is get those square root of 2 over 2 points on there, which are affected by that a value. So instead of going square root of 2 over 2, it's actually going to be 3 square root of 2 over 2. Well, if you remember that square root of 2 over 2 is 0.7-ish, then 3 times that, it's going to be about 2.1 that I need to go up and down from that midline. So if I go up 2.1, that's going to be somewhere in this area here. And down 2.1 is going to be somewhere in this area right there. All right, so what I'm going to do is draw again, see if I can get a little bit lighter color here. I'm just going to put another line there just to show where my square root of 2 over 2 points, or 3 square root of 2 over 2 points would be. Oof, it's kind of hard to keep this straight. Close. All right, so what I know then is I can add points using those red points that I have right now. I know that I'm going to have points on that square root of 2 over 2 line at my pi over 4 spots. So that's going to give us a pretty good representation. I can actually throw one more in here, right here. And then I could also put, if I wanted to, another minimum over here. And then get a really good idea of what this sine graph, negative sine graph is going to look like. So there's our graph shifted down 1 and shifted to the left pi over 2. All right, our next example here, we have a cosine graph. I'm just going to point out right away that you need to be careful. This -2 really is the k value. You know, if it helps you, if you want to rewrite this thing with that -2 and back, you can. But you really should recognize that no matter where you put it, that is the k value right there. So this thing is going to end up going down 2. I know that's going to be my shift. And since there's no parentheses in that cosine, it's just cosine of 4x, there is no shift left or right. So that a value of 3 tells us that our amplitude is going to be 3, it is not reflected, and the period is going to be 2 pi over the absolute value of 4, just 4, which is pi over 2. So our period is pi over 2, our amplitude is 3. So this thing is going to be hard to make to scale because pi over 2 is about 1.57, 1.6, and the amplitude is 3, which is quite a bit bigger than that. So I'm going to try to make it somewhat to scale by making pi over 2 actually this spot right here. Okay, and actually before I label too much in that graph, I want to think about, so I don't do what I did up here where I label something that's not the x-axis, how this thing is shifted and what the amplitude is. So if I want to make this dark line that I have here the midline, then that would be the line -2 right there, which would make this -1, and this then would be the x-axis right here. Which I don't think is a bad idea to do here because of our amplitude being 3. I'm going to be able to then put that amplitude on there that stretch this graph vertically how I should. So this is going to be 1, -3, -4, -5 right there. And then because my amplitude is 3, from that midline of -2, I need to go up 3, which would put a maximum value of 1, and then a minimum value of -5. All right, without there being a shift left or right, I don't know if making a sketch over here like we did before is really even all that necessary. Because we know it's going to start, cosine is going to start at its maximum. So its maximum value is that 1 value right there. And remember, this is your midline right here. That's the line it's going to be wrapping around. And the next maximum value is going to be at the end of the period. Well, I don't even have my x-axis labeled here yet. So trying to keep this somewhat to scale, I'm going to put my pi over 2. I'm going to label my axis up here, actually. I'm going to put my pi over 2 right there. And I'm going to put, so that is the end of my period right there. And I'm going to put pi over 4 then. It'd be half of that. And half of that would be pi over 8. It would be 3 pi over 8. So I just labeled the x-axis then. All right, so cosine starts at its maximum and it ends at its maximum. Halfway through the period, which is pi over 4 here, it's going to be at its minimum value. So trying to keep this thing to scale kind of shows how stretched vertically this is compared to that small period of pi over 2. Halfway from the first maximum right there, before it hits the minimum, it's going to go through that midline again, and it's going to go through the midline right there as well. All right, my square root of 2 over 2 points are again going to be stretched by 3, so just like before, that's about 2.1. So I'm going to go up 1, 2.1. I'm just going to put a mark there this time. So I know I'm going to have a point right there. I'm going to go down 2.1 from my midline, which would be about right there. So I'm going to have, oops, I didn't put that in the right spot, did I? It'll be right there. And I'm going to have another point right there and right there, coming back up from that minimum. And my last square root of 2 over 2 point is going to be about right there. And then I'm just going to try to make this look as nice as I can at the points that I have. Okay, and one important thing to point out here is this is just one cycle. This thing would continue on doing the same pattern forever and ever in both directions. I think what's really important here is that you know that this doesn't do that sort of thing. Make sure you show that it hits its maximum at these points that you've drawn right here. So it's coming back down. Okay, so that would be what this graph looks like. Again, it looks kind of funny because I tried to make it somewhat to scale. If you would stretch it out a little bit more and maybe put pi over 2 over here, it wouldn't be the end of the world. Just know that it's really not to scale then. All right, we're going to do one more translation here with a tangent graph. So what we have here is a negative tangent graph. I don't think we've done an example of one of those yet. So a negative tangent graph, without worrying about the shifting left or right yet, a negative tangent graph is still going to go through through the midline, which before it shifted at all is always the origin. And halfway to the asymptotes, those turning points now are going to be here and here at whatever your A value is. Well, our A value is 2. So at 2 and negative 2, but now notice that it is flipped compared to the tangent graph with a positive A value. So this is what this graph is going to look like. And the graph that I'm actually graphing here is y equals negative 2 tangent of x without any shift at all. I don't know if I actually, oh no, because we didn't draw a sketch there, so I didn't have to worry about that. So the period of this function, remember the period of the tangent graph is pi over the absolute value of b. Well, b, I'll just write that there, b in this problem is 1 again. So we simply have a period of pi, which means that these asymptotes are at pi over 2 and negative pi over 2, because then the distance between them would be your period, which is pi. So knowing all this, and actually it'd probably be a good idea to label these right now too, since they're related to our shift. Knowing all this, we're going to have to now shift this. Because of the plus pi over 4, we're going to shift this left pi over 4, which is convenient because that would just mean all these points are going to shift that much left. Okay, so I'm going to kind of keep that in mind as I'm graphing my graph over here. So let's start putting some values on the axes here. So I'm not shifting up or down, which is nice in this one. So I just want to go out kind of an even number. 1, 2, 3, 4, 5, 6. I'm going to go with 6. So these points are where the asymptotes are right now, at the pi over 2 and negative pi over 2. So I went out an even number so I could easily find that negative pi over 4 and the pi over 4 right here. I'm going to put a few other values on here, especially going to the left, since I'm going to shift this left pi over 4. So this would be negative 3 pi over 4 right there. I'll just get another one in here, and this would be negative 3 pi over 2. Actually, that would be negative pi. And then, what the heck? I'm just going to come this way and go 3 pi over 4 and pi right there. Okay, so the way that we have it on our graph is we have asymptotes right here at the pi over 2 and the negative pi over 2, right? But we're going to shift everything left, including the asymptotes, pi over 4. So I need to take that guy and then shift them left pi over 4 units, which is going to put them at negative 3 pi over 4 and at pi over 4. There's my asymptotes. And I'm only going to draw one cycle here. Before I shifted it, it went through the origin right there. But I need to shift that left pi over 4 as well. So I know it's going to be crossing through the midline, which is my x-axis in this case, at negative pi over 4. And then halfway to the asymptotes, it's going to go up to the a value and down to the opposite of the a value. Well, that's 2 in this problem. 2 actually is going to be pretty high on this thing here. I'm just going to call this 1, 2, negative 1, and negative 2 here. So I need to make sure that I put my points, the turning points, at 2 and negative 2. It's negative though, it's a negative graph, so I want to put the higher point on the left and the lower point on the right so that it's opening down. Those turning points are always halfway between that point and the asymptotes. That's where those turning points are. So my graph is going to end up looking, this one cycle is going to end up looking, let me make that a little bit nicer. Like that. Now really it's only necessary for us to draw one cycle here, but note that this thing does continue on forever. The period is pi, which is the distance between those asymptotes. So I would have another asymptote right over here at 5 pi over 4, and would cross again through that 3 pi over 4, and then I'd have another turning point here, and at pi I go down to negative 2. So there are more cycles to this function. We're just usually only drawing one just for time purposes, but there are, it continues forever left and right, and this is what a translated tangent graph looks like. If we had to shift it up or down, then we would take all of those points and move those up or down as well if there was some sort of k value out here, but we didn't have to do that in this problem.